Okay, students, let us start the today's session. So in the previous class, we completed the uniform plane wave and the free space and the propagation constant gamma is equal to also. Okay. When I was deriving these equations, we got the velocity, intrinsic impedance eta, and gamma, the propagation constant. Now, in the previous class, a small mistake we did. That is, see, we find the velocity v is equal to omega by beta, and another formula is there for velocity, the under root of mu epsilon, and it is also equal to the wavelength f lambda. Okay, and intrinsic impedance eta is equal to under root of mu by epsilon, and it is also equal to, we derive this equation from the EM plus by HM plus only, the ratio between of electric and the magnetic field, or the minus EM minus whole divided by the HM minus HM minus. So this is the equation we got, and it is approximately equal to the 3 into 10 to the power of 8. And the intrinsic impedance is approximately equal to 120 pi, or it is also 377 ohms. Okay, impedance. And also we derive the expression of gamma is equal to, by using the Maxwell's equations only, gamma is equal to under root of j omega mu whole multiply with the sigma plus j omega epsilon. Okay, this is a gamma actually. And this intrinsic impedance, what I told in the previous class, it is inverse actually. I told the sigma plus j omega epsilon by the j omega. It is not that. J omega mu by sigma plus j omega epsilon. Okay. In the previous class, we did the mistake in this intrinsic impedance. The formula is, I wrote sigma plus j omega epsilon by the j omega mu. Actually, this is the right intrinsic impedance, j omega mu by sigma plus j omega epsilon. Okay, the ratio between of these two terms here, the gamma. And this gamma is equal to, we have alpha plus I beta also. I beta. In that, alpha is equal to omega under root of mu epsilon, or omega epsilon mu epsilon mu epsilon by 2 and whole multiply with under root of 1 plus, the term is the ratio of these two, the sigma by omega epsilon whole square. Okay, omega epsilon whole square and minus 1. The same thing we'll get in the beta also. The beta is equal to the omega under root of mu epsilon by 2 and whole multiply with under root of 1 plus sigma by omega epsilon whole square plus 1. It's a plus symbol here. We already derived that velocity, the v is equal to 1 by mu epsilon and the eta is equal to mu by epsilon. Mu by epsilon. So that we'll get from these equations only. You see here, sigma plus j omega epsilon. In the free space, the conductivity is a 0. In the free space, the conductivity is a 0, means sigma is a 0. If sigma is equal to 0, the j omega mu by j omega epsilon. So in free space, you see here, in free space, means the dielectric, perfect dielectric. The conductivity is a 0. The conductivity means the sigma. Sigma is equal to 0. Then it becomes of eta is equal to under root of j omega mu whole divided by that sigma is a 0. So j omega epsilon. Okay. Then j omega get cancelled here, and we get mu by epsilon. Okay. So whatever we have here, the eta is equal to. Following. Mu by epsilon. That is derived the uniform plane wave in a free space. If it is a in perfect conductor, j omega mu by sigma will get j omega mu by the sigma. So these are all the formulas you can use to find out the uniform plane wave in perfect dielectric, uniform plane wave in a perfect conductor, and uniform plane wave in lossy and lossless dielectric, and the practical dielectric also. Lossy and lossless. Lossy and the lossless, alpha is equal to 0. There is no any attenuation, there is no any loss in that. Lossy means there is an alpha is present, attenuation constant is present, there is a lossy dielectric. Okay, let you go for using this, all the equations. You go for derive the expressions for the uniform plane wave in perfect dielectric, first of all. Perfect dielectric. So uniform plane wave in perfect dielectric. Dielectric means the epsilon is present. Sigma is a 0. So that wave is propagated through a boundary conditions. The incident beam, the propagated constant, the propagation constant, gamma is equal to j omega mu sigma plus j omega epsilon. This is the actual propagation constant equation. It is equal to the alpha plus I beta. Alpha plus I beta. So we are saying it is a perfect dielectric. Perfect dielectric means j omega epsilon is the 0 value. J omega epsilon is a 0. It's a perfect dielectric. It's not the 0. Sigma is a 0. Perfect dielectric means the conductivity is a 0. So conductivity is a 0. Perfect dielectric means gamma is equal to under root of j omega mu, and sigma is a 0 means we have only the j omega epsilon. J omega epsilon. That becomes of j square omega square, j square omega square mu epsilon under root. And it is equal to of j omega under root of mu epsilon. Okay. Now it is equating with alpha plus I beta or alpha plus j beta. Let us take an imaginary function only, is equal to 0 plus j omega under root of mu epsilon. Okay. So now what is alpha? When equating these two functions, attenuation constant is a 0 and beta, the coefficient of the imaginary. Imaginary is omega under root of mu epsilon. So the two conditions we get when the uniform plane wave in a perfect dielectric. In a perfect dielectric means attenuation constant is a 0. And similarly, the eta also, what I derive now, the eta is equal to j omega mu by sigma plus j omega epsilon. When it is a perfect dielectric, because it's a uniform plane wave is a perfect dielectric, it becomes of sigma is a 0, omega by epsilon, omega by epsilon. So we got the three terms, attenuation constant alpha, attenuation, and it is a phase constant. And eta is the intrinsic impedance, and gamma is a propagation constant. Propagation constant. Okay. Now, if I'm saying here, it is a lossless dielectric. It is a lossless dielectric. Why it is a lossless dielectric means, if no attenuation, alpha is a 0, simply we can say it is a lossless dielectric only. When there is a alpha value, the minimum value, it is an ideal condition only. Ideal condition, sigma is 0, we are taking, and sigma having some value, it's a practical dielectric is a difference. But ideal condition only. For ideal condition or the ideal perfect dielectric, if I am assuming that it's not the practical dielectric, perfect dielectric means consider it as the ideal. Sigma is equal to 0, alpha is equal to 0 will get in the propagation constant of the gamma. And beta is equal to omega under root of mu epsilon. And see here, we have the alpha and the beta functions. Alpha and the beta. Let us see here whether it is alpha is equal to 0 or not when the conductivity is a 0. So when the conductivity is a 0 here, sigma is equal to 0. Sigma 0 means 0 square is a 0 here. 1 plus 0 is a 1. Under root of 1 is a 1. 1 minus 1 is 0. 0 into anything is a 0 only. Alpha is equal to 0. We'll get this function. Alpha is equal to have omega under root of mu epsilon with under root of 1 plus, that sigma is a 0 here because of the conductivity is a 0, minus 1. So under root of 1 is a 1 and 1 minus 1 is a 0, becomes of 0. Alpha is equal to 0 in a perfect dielectric. And coming to the beta here, let the beta is equal to omega under root of mu epsilon by 2. And similarly here also the sigma is a 0. Sigma is 0, 1 plus, but here it is not the minus 1, plus 1 in the beta. Under root of 1 is a 1, plus 1. So 2 and this function is get cancelled. Then finally we got 2 to get cancelled, omega under, we got when we take in the propagation constant j omega mu sigma plus j omega epsilon, substituting the gamma is sigma is equal to 0, j omega mu epsilon. What is alpha here? Alpha is 0 and beta is equal to omega under root of mu epsilon. So here omega under root of mu epsilon. the phase constant. And intrinsic impedance, sigma is equal to 0, j omega get cancelled, under root of mu by 0. The phase constant is with respect to the frequency, the angular frequency here, the omega depends upon the frequency. Omega is there. And intrinsic impedance is not depends upon the frequency. It is a constant value around 120 pi or it is a 377 ohms. Only the beta is depends in the frequency. Okay, in perfect dielectric. Then we can call it as a lossless. And alpha is equal to 0, loss dielectric. Lossless dielectric. Alright. When it is alpha is equal to 0 minus 2. Then what is a lossy dielectric? The lossy dielectric. So lossy dielectric means actually the sigma is not at all the 0, and I am taking here, let us see, the lossy dielectric. Lossy dielectric means let us see, same I am taking the gamma is equal to under root of j omega mu sigma plus j omega epsilon. Okay, take the j omega epsilon is a common term here. Gamma is mu. In this function, I'm taking as j omega is a common term. So 1 plus sigma by j omega epsilon into j omega epsilon. Okay, so you got the same thing. 1 into j omega epsilon is a j omega epsilon. Now the gamma is equal to alpha plus I beta. Alpha plus I beta, that is equal to, here the j omega is at j square omega. Under root it becomes of j omega. Under root of mu epsilon. And this function is also in under root only. Under root of 1 plus sigma by j omega epsilon. Now we can write it as a 1 by j as in the numerator. It becomes of minus j, 1 minus j function. So that is equal to j omega under root of mu epsilon, and again the another root of 1 minus 1 by j, I am writing it as a j here, and sigma by omega epsilon. Sigma by omega epsilon. Okay, and that is alpha plus I beta. But here see, the alpha is not equal to the 0. It's having the imaginary term and it is multiplied internally. The j and the j is a j square. It becomes of minus 1. And we have the alpha is also. Alpha is not equal to the 0 here. Some value is there that is minute. Okay. A small value. Alpha is not equal to 0 here. And beta definitely it becomes omega under root of mu epsilon only. Whenever if it is multiplication factor of with 1, the real term will get whole power 1 by 2. You can take it as whole power 1 by 2. And by using the binomial equations, you'll get 1 plus n into x. Actually, it is a 1 plus nx plus n into n minus 1 by 2 x square plus n into n minus 1 n minus 2 by 3 factorial into x cube and so on. If you are neglecting the higher order terms, you take only the first two terms, 1 plus x. That n will get from the power. The power is 1 by 2 there under root. 1 plus 1 by 2 into the x term is j into sigma by omega epsilon. That is a perfect, not the perfect, it's a practical dielectric. Practical dielectric. The lossless lossy dielectric, alpha is not equal to 0 and beta is becomes of a similar way, the omega under root of mu epsilon. Mu epsilon. And what about the intrinsic impedance? Having some small value here on the alpha. And intrinsic impedance eta is equal to, we have the formula is that the j omega mu and under root of, I take the common for the j omega in the denominator, j omega epsilon, it becomes of 1 plus sigma by j omega epsilon. Okay, and this j omega get cancelled, and we get the eta is equal to mu by under root of mu by 1 plus sigma plus j omega epsilon. If you write this in the two terms, the intrinsic impedance eta is equal to under root of mu by epsilon, and also the another root is there, another root that is 1 by 1 minus j sigma by omega epsilon. You see, in the previous lossy dielectric and this lossless dielectric and lossy dielectric, the term whatever we have, it is there, the under root of is a beta value omega into under root of omega epsilon mu into epsilon 1 minus under root of 1 minus j sigma by omega epsilon. The term is there, the minimum value. And similarly, intrinsic impedance also, see, under root of mu by epsilon whenever if it is a perfect dielectric and is a lossless dielectric also. The lossless alpha is equal to 0 means perfectly I am taking the sigma is equal to 0, mu by epsilon. But now the mu by epsilon and it is multiplied with another factor. When there is a lossy dielectric is there, this much factor is multiplied for the intrinsic impedance also. That is under root of 1 by 1 minus sigma by omega epsilon. And here it is not inversely proportional, the directly proportional 1 minus j sigma by omega epsilon. This is a factor we have to get it is a alpha is not equal to the 0. So it is a lossy dielectric. And coming to the uniform plane wave in practical dielectric, the third one is the second one, uniform plane wave in perfect dielectric, that too, it is a lossy dielectric, and these are two in B. Let us take the B on lossy dielectric, the same thing. Now we'll go for the uniform plane wave. Uniform plane wave in practical dielectric. Practical dielectric. Same function, again the same, you can take the gamma is equal to under root of j omega and whatever we have got, it is alpha and the beta values. The gamma is equal to the taking of j omega epsilon is a common, j omega under root of mu epsilon, and it is also multiplied with under root of 1 minus j sigma by omega epsilon. This is a factor actually. It is a perfect conductor, less than the one, it is a perfect dielectric. Now we are going to derive the equation for the practical dielectric. Practical dielectric means alpha is there and the beta is also there. Both are not equal to, alpha is not equal to the 0. Okay. Now from this equation, I am using the binomial theorem, 1 plus x n into x plus n into n minus 1 by here the 2 factorial actually, and this is a 1 factorial. There's 1 with a 0 factorial, my students. Okay, no need to write a 0 factorial here. Plus x square plus n into n minus 1 n factorial into x cube so on, x cube so on. So as this equation you see here, this is also you can written as j omega under root of mu epsilon, and this function I have write as 1 minus j sigma by omega epsilon whole power 1 by 2. Okay. And this is not the minus, students, it's a plus, not the plus. Okay. The minus only, you can write it as a j here in the denominator. Write it here itself, no need to change the j omega. Okay. First of all, keep this j omega on. And this is also plus denominator j only. Okay. Now it is a 1 plus x whole power n. So I'm taking the only the first two terms, neglecting of the higher order terms, is equal to 1 plus n is a 1 by 2 here, 1 by 2. And the x term is a sigma by j omega epsilon. Okay, I'm neglecting the higher order terms. So it is in the form of 1 plus sigma by, the x term is a sigma by j omega epsilon whole power 1 by 2, where n is a 1 by 2 and x is a sigma by j omega epsilon, neglecting of higher order terms. It multiplied with the j gamma is equal to now j omega under root of mu epsilon whole multiply this function. Whatever we did the expression by using the binomial theorem, 1 plus 1 by 2 sigma by j omega epsilon. Now you can multiply this j omega under root of omega epsilon with 1 and the second term 1 by 2. So j omega and j omega get cancelled here. Okay. Write in the next equation, next page. Gamma is equal to j omega under root of mu epsilon whole multiplied with 1 plus 1 by 2 sigma by j omega epsilon. This is the equation we got in the previous page. Okay. Multiplying the terms j omega under root of mu epsilon plus, and this term with this second term, j omega get cancelled, 1 by 2 under root of mu epsilon, and also the sigma is there, sigma by epsilon. Sigma by epsilon. Now that is equal to j omega mu epsilon plus sigma by 2. I'm writing it as a sigma by 2. See, under root of epsilon is there and denominator having the epsilon. So under root of mu by epsilon. Mu by epsilon, because the root x by x is that 1 by root x only. So root mu by epsilon. Now this is the equation equal to the one the alpha plus j beta. The propagation constant is equal to alpha plus J beta. What is alpha now? Alpha is equal to the real term. The real term is a sigma by 2 under root of mu by epsilon. See here it is not the equal to 0. Okay, now even it is a dielectric, that is a practical dielectric, that sigma is not equal to the 0. Okay, and whatever the beta is the same. Even the lossy dielectric or lossless dielectric and in the practical dielectric, beta is whatever the same, omega mu into epsilon is a factor. Okay, alpha is not equal to 0 in the practical condition or practical dielectric. Coming to the intrinsic impedance also. What is the intrinsic impedance? Eta is equal to under root of j omega mu and whole divided by j omega epsilon whole multiplied with 1 plus sigma by j omega epsilon. This is the equation we have. And here the j omega get cancelled. Eta is equal to under root of mu by epsilon. And another equation is there. This is 1 by under root of 1 plus sigma by j omega epsilon. Okay. But here the 1 plus n into x we wrote for that of 1 plus x whole power n. But here whole power minus 1 by 2 we got. So eta is equal to under root of mu by epsilon, and this is the equation we have 1 plus sigma by j omega epsilon whole power minus 1 by 2 because it is in the denominator. Whole power minus 1 by 2. Now the same, the binomial theorem we can use as of 1 plus x whole power minus n means 1 minus nx plus n into n minus 1 to factorial x square. Alternatively, you will get the minus 1. Okay. So 1 plus, after the neglecting the terms of 1 x whole power minus n is becomes of 1 minus nx only. I am neglecting the higher order terms. What is the n here? 1 by 2. What is the x here? Sigma by j omega epsilon. So now the eta is equal to, we got under root of mu by epsilon. And for this, apply the binomial theorem. And for this function, apply the binomial theorem. 1 minus nx, 1 is a multiplication factor of 1 minus n is 1 by 2. And sigma by, x is sigma by j omega epsilon. This is the equation for the eta. We got the eta is equal to under root of mu by epsilon 1 minus 1 by 2 sigma by j omega epsilon, or otherwise you can take this j as in the numerator, it becomes of minus, then it becomes of 1 plus j sigma by 2 omega epsilon. Along my distance. Like this, we can also find the uniform plane wave for the perfect conductor also. So we derive the expressions for uniform plane wave in the dielectric and lossless dielectric. So the lossless dielectric means alpha is equal to 0 and the beta is equal to omega under root of mu epsilon. But it is depends upon the frequency. It alone of frequency is alpha attenuation constant, and alone of intrinsic impedance is also alone of the frequency in the lossy dielectric. Coming to the lossless dielectric. See, this is a lossless dielectric. The lossless dielectric intrinsic impedance is not depends upon the frequency. Attenuation constant is not depends upon the frequency, and the beta is only depends upon the frequency. That is a lossy dielectric, and not the lossy. And lossy dielectric, see, the lossy dielectric alpha is not equal to 0. Alpha is not equal to 0 means it having some term is multiplied 1 minus j sigma by omega epsilon, and beta is the same, omega under root of mu epsilon is there. So alpha is depends upon the frequency, and the beta is also depends upon the frequency, and eta is also depends upon the frequency. So definitely there is a loss attenuation constant is there. Definitely can be having the loss in the uniform plane wave in a dielectric medium. It passes through the dielectric to the dielectric, the boundary between. And coming to the practical, these are the ideal conditions only. And the practical conditions we can take as by using the binomial theorem, the binomial expression 1 plus x whole power n or 1 plus x whole power minus n. Minus n means alternately we'll get the minus, and plus n means we'll get all the values is a plus, and with the half factorial it increases. So for this case, we got alpha is equal to sigma by 2, and beta is equal to omega under root of mu epsilon, and eta is equal to square root of mu by epsilon into 1 minus 1 by 2 sigma by j omega epsilon. Now you can see the eta is depends upon the frequency and beta is frequency. Alpha is not depends upon the frequency, but it having some values. It's not equal to the 0 practically. Even if it is a perfect dielectric, there is a conductivity is there. Some small amount of conductivity. Understood? Now coming to the perfect conductor or the perfect dielectric, the perfect dielectric is completed. Perfect conductor, uniform plane wave, or perfect conductor. The same thing, gamma is equal to under root of j omega mu, and sigma plus means epsilon value is a 0. So there is no any dielectric, only we have the conductivity. So gamma is equal to under root of j omega mu into sigma. Epsilon is equal to 0, not alone of epsilon. Omega epsilon is equal to 0. From the equation of sigma by omega epsilon is greater than 1. Using this condition, the conductivity is more here. The epsilon, omega epsilon is equal to, since omega epsilon is equal to 0, and gamma is equal to, we can write as under root of j and under root of omega mu sigma. What is under root of j means 0 plus 1j. 0 plus 1j. When you convert into the polar form, 1 with an angle of